Hello, viewer. Welcome in this session where we are going to look at manage food laboratory activities. This is the third running unit in the module called Food Plant Management. Okay, let's go into it. Now, for food managing food laboratory activities it involves a lot of activities, including knowing where we are working at. For example, the general rules that governs food laboratories or in general food facilities. But we shall now go into these five components, such as introduction, primary goals, areas of focus, and how we can get there, and of course, a brief summary of what we are going to cover. Okay, let's go. So now, as introduction, this chapter attempts to bring together science and topical aspects of laboratory operations to help managers to develop a quality system for managing laboratory samples from the time of collection to the final stage of disposal in a manner that will ensure reliable results. In addition, it will help us to obtain a clear overview of the complex science involved and its application to the production of reliable results as required by ISO 17025 from 2017. Now, what is the primary goal of this laboratory management protocol? Now, the primary goals of these laboratory operations are considered as analogous to a manufacturing process where the industrial process is substituted by the analytical process, whose production are analytical results. Process control is then an essential element of the quality management system. So it refers to control of the activities employed in the handling of samples and the examination processes in order to monitor the accuracy and precision of the complete analytical process. So what do we mean by the accuracy and precision? These are the two most important components of the laboratory results or data in general, measurements, because our measurements are supposed to be accurate and precise. Of course, if they are accurate and precise, they have what we call reproducibility. They are somehow relevant. They are true and closest to the true value. When we say accuracy, this is how a measurement is closer to the true value. While precision, this is how measurements are likely to come close. Like they don't, it's not made to be close to the true value, but if they are somehow reproducible and without much deviation, results or data measurements is likely to be like the previous one. They are somehow close. So we say that they are precise. Okay, let's go. Now, the primary also goals for this laboratory management protocol is that also the goal of the quality control is also to detect, evaluate, and correct errors. So, what are these errors in the laboratory? We have so many errors, including that they are divided into two classification: random errors and non-random errors. Okay, this is due to the test system failure, for example, environmental conditions, or operator performance before results are reported. This session provides practical tools for managing more effectively an analytical laboratory and guides the trainees to carefully evaluate the variability of the analytical process in order to improve it. So the guiding principle is that quality results are not produced by the quality of the results is improved. So sorry, the guiding principle is that quality results are not produced, but the quality of results is improved by controlling all stages of the process, including sampling. Yeah, if you fail to correct your sample very well, it means your result will not be accurate and precise. Of course, it will not be close to the true value, and its replicability or reproducibility it will be somehow something else. Of course, it will deviate. Now, the areas of focus in this chapter, we shall now look at we've done some of the introduction, though we are not yet able to see this ISO standard. I will show it in upcoming slides. Then in the next slides, we are going to discuss about this one. And chapter two, which also is essential for quality management in a chemical testing laboratory. And what about chapter six? We shall deal with control charts and process capability if we have time, or we can go up to these six and seven in upcoming videos. The control charts and the process capability, and the last but not the least is the risk management. So now, how can we get there in order to have a good laboratory management? First of all, we have to lay our hands on these accurate and precise results. That is the main focus. Are our results accurate and precise, good, presentable, something reliable that we can tell people that if it is the aflatoxin that we are determining, we have to convince people or to tell people the truth that we have found this data and it is accurate. We have used standards that are relevant, that are correct to the test, so that people will now gain, which so that people will have trust within our works or towards our results. Now, for us to have accurate and precise results, so many things are involved, like personnel. Personnel, they should be, of course, competent. They should be like regularly attaining the trainings toward these laboratory practices, such as those standards that are relevant to keep them updating their knowledge, skills, and attitudes toward these laboratory management procedures. The second being the machines, tools, equipment. They should always have selectiveness, robust, and calibrated over time because very often these equipment get overused or they fade away. So we need to replace them or to fix them regularly. Those that need calibration, they should also undergo calibration process so that they can give accurate and precise results, as well as also environmental conditions. We have to make sure that the environment is clean, is well maintained, is sustainable for our work to keep going on and on. Also, we should get there for good laboratory management practices by also incorporating inter-laboratory measurement tests. Yeah, this is something that in Rwanda we do. For example, many institutions they participate in what we call inter-laboratory measurement test. This activity usually is conducted by Rwanda Standard Boards and other institutions. They join the measurements so that they now trace where calibration is needed, where trainings are needed, and where certifications are needed so that we keep on the right track to maintain the integrity of our laboratories and our measurements, of course. Now, this interlaboratory measurement test involves pursue scalable customer service through sustainable strategies, yeah, to win their hearts so that become um, they become more and available to our services or products. And again, we have also to work with national, regional, and international organizations for standardization and regulations. This is what I said. For example, RSP usually conducts this inter-laboratory measurement test to check for reliability, to check whether we are still on the right track with their measurements, and also we always know where we are so that we can keep improving by also participating in these interlaboratory measurement tests. The third being to work with meteorological stations for calibrations and maintenance. We've said this one over and over again. There is no need to repeat. The third aspect for us to get there is to supply chains and accreditation. Chemicals and reagents, trusted and reputable supplies only. So we give the relevant institutions or suppliers that are qualified to supply chemicals and reagents without uh, being caught in floods or in illegal markets and so on and so forth. Also, we have also when we are dealing with supply chains and accreditations, we also make sure that we have the right tools, machines, and equipment that are updated with the newly developed technologies so that we tackle many challenges. But if we are using the old version technology, we are left behind. Yeah. Also, the accreditations of lab to increase the trust and reputation. Yeah. So let's go now in the chapter one, which is the introduction and of, for example, this ISO 17025. These laboratory measurements are playing a crucial role in a modern society since it is the basis or is the basis of the important decisions. In fact, based on such decisions, national and international regulations concerning commercial, legal, medical, and environmental impacts are set in force. For what concern foodstuff, their value in trade depends strictly on the measurements that determine the degree of quality. However, results of measurements may be reliable and to be trustful should be obtained in competent and well-organized laboratories working with quality system in place. The ISO or EAC 17025 General Requirements for the Competence of Testing and Calibration Laboratories is the global quality standard for testing and calibration laboratories. This standard specifies the performance requirements for the procedures in a quality system and laboratories can determine their own pattern for carrying out procedures. Now, accreditation involves a third party or accreditation body attesting the technical competence of laboratory based on a set of accepted standards. Accreditation bodies that recognize the competence of testing and calibration laboratories use ISO 17021 as the basis of their accreditation. Now, the ISO 17025 is divided into 8 clauses, as we shall see in this link that I have attached here. We shall see that it has so many clauses, but the list that we can now discuss are 8 clauses. Two annexes, like A, which is about meteorological traceability, and B, management system options, and one bibliography section. The most important clauses are clauses 6, 7, and 8, describing management and technical requirements. In addition to official requirements, these clauses are also include notes with further explanations and recommendations recommendations. Below are reported some brief considerations on each point of the known ISO 17025 and where appropriate some difference with the old norm of this standard are discussed also. To assess the ISO standard 17025 standard, we have to, for example, click here. If we click here, we automatically go to this standard. Yeah, this is the standard. You can see that this standard has like about 80 clauses. Like you can see that this is one, two, three, four, one, two, three, four, five, six, seven, eight. You see that there are eight clauses, and of course we have Annex A, which is about meteorological traceability, and Annex B, which is about management system options as well as bibliography. Now, since this standard, it is what we are reading is the sample. You have to buy it. For example, if you want to buy, you click here and buy it. Okay, you can see that this is SUS currency. So it is not something that is cheap. Okay, It is something that is somehow expensive. Only organization can buy it. Okay. Yeah. Now, for example, what we are interested in, we can now look at, for example, the introduction of this standard. So now this standard document has been developed with the objective of promoting confidence in the operation of laboratories. This document contains requirements of laboratories to enable them to demonstrate they operate competently and are able to generate varied results. Laboratories that conform to this document will also operate generally in accordance with the principles of ISO 9001. This document requires the laboratory to plan and implement actions to address risks and opportunities. Addressing both risks and opportunities establishes a basis for increasing the effectiveness of the management system, achieving improved results, and preventing negative effects. Now, the laboratory is responsible for deciding which risks and opportunities are needed to be addressed. Are needed to be addressed. The use of this document will facilitate cooperation between laboratories and other bodies and assist in the exchange of information and experience and in the harmonization of standards and procedures. The acceptance of results between countries is facilitated if laboratories conform to this document. Okay. In this document, the following verbal forms are used. For example, shall, which indicates a requirement. For example, should, it indicates a recommendation. May indicates a permission, and can indicates a possibility or a capability. Further details can be found, for example, in ISO directives, for example, part 2. For the purpose of research, users are encouraged to share their view on this document and their priorities for change to future editions. Click on the link below to take part in the online survey. For example, you see that even this standard, it, they prepared a way for continuous improvement because it normally has edition or versions. This one we are seeing is ISO 17025 of the version of from that was produced in 2017. Okay, this is the English version. Yeah, we can discuss more about this document, but until we have the whole documented to see these important clauses, which is clause 6, 7, and 8. Of course, we cannot get it until we have purchased it. Okay. Yeah, let's come back to our slides. Now, in summary, the quality demand on laboratories continue to increase, and we need to have in mind the customer or low requirements of the produced food products, running more quality control samples, or selecting stricter rules more external quality assurance will not necessarily achieve this end. Processes must be put in place to maximize error detection and improve performance without necessarily increasing laboratory costs. So thank you for watching. Bye bye.